Hey, so this devlog is about a project that I want to start. Well, I have started. Is to write a game without any 3D engines, effectively from scratch. The game being a simplistic city simulator. At the very least, at the end of the project, I want to be able to put down some roads and have some buildings come up. But it is mostly a hobby, so I don't know how far I'll take it. I'm going to be working on it on my spare time. Programming wise, I'll be writing it in C++23. I want to support both Windows and Linux, but to start with, it's just on Windows. Developing a Linux desktop, and once I have that, I will switch to uh, adapting it for Linux. API graphics API wise, I'm going to use Vulkan 1.3, which works on both the OS, and given that it's targeting the desktop, 1.3 is just fine. Audio API, I haven't figured this one out. I need to do more research because I don't know what the current state of audio APIs is, especially cross-platform audio APIs. I know like 15 years ago, OpenAL used to be a thing, but I don't think it is anymore. Again, needs more research. Tooling wise, I'm using MSVC on Windows, Clang on Linux, VC package for package management, CMake for the project management, Ninja for a build. So Ninja will actually call the compilers, Clang tidy, Clang format, and obviously Git. At present on Linux, only Clang supports standard modules. GCC does not. I don't know what the GCC uh, roadmap is for standard modules. It should be coming, but they haven't implemented it yet. Um, Clang's support for standard modules only works with libc++, which is LLVM. It does not work with libstdc++, which is the GNU one, or GCC one. So you have to use libc++. Thankfully, CMake takes care of it. We don't have to worry about it. But we do have to tell VC package to use libc++. And once I get down to the Linux side in a future video, we'll point that out as to how I had to make it work. References, I'm following kind of at a high level Travis Werman's Kohi engine. Obviously, Kohi is a very C-based engine. It's very low level, and he kind of goes through a lot of stuff from the ground up, which is great. But I don't care to follow and do all of that, given C++ gives me a lot of that out of the box. Also been following the Vulkan tutorials and VK guide, more so the VK guide than the tutorial, because that seems to be more current. And then as I go along on this project, I will add other items in this list. Stay tuned. Project setup, I think this is a very standard layout for a project, at least C++ projects in my experience. I have a source folder where all the source files are. There's a builds folder where all the intermediate build files go, and then a bin folder where the output goes, the compilation output. The CMake folder has some CMake scripts in them that I've written to help with the project. .vs Code there is what VS Code likes to put its setting in. So that's what that is. Under the source, there are several subfolders. Um, each subfolder has its own purpose. So there's one for the executable, one for the platform-specific library, which I'm building as a shared library, or not a shared library, but a static library. The graphics and audio will be a shared library, so there'll be like a DLL or a .so. Yeah, so let's see how I've got it going so far. And hopefully I'll point out some places that I'm not happy. And if somebody has a good way to deal with it, I'm all ears. Okay, so to start with, I'm using CMake presets. This takes care of all the platform-specific configuration. So stuff like the compiler, how I want to, the compiler to use per platform, all the different build presets on that platform. So here I have like debug, release with some debug info, all using MSVC, run by Ninja, using VC package for package management, and some base directories. Pretty standard, nothing special. Only thing special that I have not seen others do. So, but people have to do something similar. Maybe there's different mechanisms. Is this part? So with MSVC, just putting it in a language mode does not set all the standards compliance. You have to kind of force it into standard compliance. So these flags do that basically. And this applies to regardless whether it's a executable or a library. I want these flags applied for every project. Okay. The root CMake itself, pretty simple, nothing complicated going on here other than a call to this, which sets up the import std functionality that CMake now supports. It supports it as a 3.30 as experimental. So this is the magic string that enables it. The app as well as all the libraries are pretty much set up the same way. I have some platform specific definitions that I get, uh, which then get used here, as well as platform specific link options. This is above and beyond what I have in the preset. And then we tell it what our module files are and what libraries we are using. All right, so we'll go through all, as I said, all the libraries are set up the same way, so they get consumed the same way. Platform specific definitions, here is a Windows one. Linux will have something similar. The only unique bit here is this. On Windows, when you tell it that you want a Windows app, it wants to use WinMain by default. And CMake doesn't really have a good way to say don't use WinMain. So I'm forcing it to use plain main entry point. So this allows me to use int main as opposed to WinMain. Okay. And then like I'm importing all the stuff, but not everything will work with import. And in places where import doesn't work, I have either a precompiled header or I'm including like a normal C++ include. The other thing I'm doing, hopefully out of laziness, I don't know how well this will work, but if the program is run from a command line, then it will output all the standard outputs, so print line, std errors, all that stuff. Um, and the way this works is that it detects whether it's running from a command line. Now, this is Windows specific, but I believe we can do something similar on Linux as well. Beyond that, I just have clock, my window. This is the input, graphics, some callbacks on window events, and then a check. If the escape is pressed, then exit the program. Okay, there's a message pump and an input processor right there. Clock is a std chrono. It's part of the C++ standard using a high resolution clock. This works on every platform that I know of. Well, almost, but definitely Windows and Linux. So not a problem for this project. And this gives me nanosecond resolution, which is pretty good, or good enough, I guess. On the Windows side, or other windowing side, I'm using the same approach that Travis has in his videos, where we define a platform-specific struct, which based on what platform you're on. So here we're looking at Windows, right? Yeah, Windows up here. And in Windows, I want hinstance and hwind. On Linux, it'll be something else. And then this gets used elsewhere within the application. So for example, input needs to know what platform it's running on so that it can hook into the input mechanism for that platform. So when you create the input, you pass in a pointer to the platform data, and that's how it figures it out. Right? And it's just a pointer. It doesn't need to delete. It's a non-owning. The concept that I'm using is that if it's a raw pointer, it's non-owning. But if it's, we go here, it's the unique, it's an owning pointer. That way I know if I need to delete something explicitly. Input is raw input on Windows at least. So this is all just logic to set up raw input on Windows. I'm using buffered raw input. So it'll buffer all the messages and then process them all at once. But I have written up logic for unbuffered raw input. And it's a compile time flag. I can enable and disable it or flip between the two with the compile time flag. I just find that the buffered raw input seems to work better. So that's what I'm using. Input button states, I'm just doing it very simply with a bit set. So if the button is down, the bit value is on, or true. If button is not pressed, the bit value is false. Right? And then all I'm doing is I have some functions that check those values. Similarly, I have some other functions that let me set the button value manually if I so choose. Similarly, set the axis values as well. As a get axis, which are mouse axes, and it'll do all mouse axes, so X, Y, mouse wheel, X and Y. So I can show my axes here. Yeah, RX, RY, right? Eventually I'll add gamepad support, but I haven't figured out whether I want to use raw input for gamepad or something else. As for things I am not too happy with how I've written is specifically around Windows event handling. So what I've done is I have a set of structures, structs basically, and a variant on each of those. That like so, it's basically a union type, and depending on which structure is called as part of the variant, I'm switching on a case by the index of the variant. Now, this is the part I'm not too happy with. I don't think this is elegant because if I have to modify the variant, I have to modify the case. I have to remember to do this. If I forget, it won't work. There has to know what that is. But if somebody else knows, let me know. If not, eventually in the future, if I do figure it out, I will change it. Beyond that, I mean, it's a pretty straightforward system. If I run it, it'll write out where it's running from. I can close it, and it'll close. Pretty straightforward. Yeah, so far so good. I think with this, the next one will be next video that I make, rather, I should say, will be after I figure out the Vulkan layer. Until then, thanks.